Good evening, everybody, to our technical meeting for the 25th of August 2022. We'll just run through some housekeeping items before we move on to the actual presentation. Got our meeting procedures, introduction to AACE International and the AACE Australian section. We'll then be moving on to our webinar, Project Planning, Preserving the Project Critical Path. Final questions to the speaker, and then there'll be a networking with open mic session. Attendees will be muted during the presentation, so I'll do that in a minute. If you would like to ask a question or make comment, let us know using the Teams meeting chat feature. The speaker will pause during the webinar to answer questions. We'll also make this webinar available on the AACE Australian section YouTube channel after the session. It'll also be posted as a podcast on the AACE Spotify channel. Certificate of attendance will be distributed to AACE members only, valid as CPDs and CEUs. Please email us at info@aacei.org.au. Details of future events can be found at our website on aacei.org.au, which also includes a link to our YouTube channel. About the AACE, formerly known as the Association for the Advancement of Cost Engineering, but we just go by the four-letter acronym now, serving the total cost management community since 1956. We're committed to the constructive exchange of ideas between members, development of technical guidance and quality education, recognition of subject matter experts. The AACE Australia Board, and I just noticed that should be 2022. Lou Vidotto is our President and Queensland Area Chair. Alberto Sanchez is our New South Wales Region Chair. Our area representative for Western Australia and Northern Territory is Alan Crowe. In Victoria, we've got the Vice President, Yazid Abelhadi. The Secretary, myself, Cameron Baker. The Treasurer, Frank Vera. Our Training and Development Coordinator is Paul Harris. Our Website and Social Media Coordinator is Keith Farrell. Sponsorship and Alliance Coordinator is Michael Wallace. And the Area Chair for Victoria and Tasmania is Val Matthews. In South Australia, we have our Reporting Coordinator, Rohith Ravikumar. We've still got some volunteering opportunities open. We'd like an events coordinator who organises things like these webinars, membership secretary, and a publications coordinator. So if anybody's interested, get in contact with us and we can have a chat. Okay, please welcome Lou Vidotto and Michael Wallace to present Project Planning, Preserving the Project Critical Path. So I will you got the presentation ready, Lou?
I do.
You can take control.
Thank you. I guess you guys can see that.
Yes.
Okay, great. Okay, so welcome everybody. This is the August 22 webinar for AACE. The title today is Project Planning, and it's pitched at sort of preserving the project critical path. Michael Wallace and I got our heads together and we put we share some notes and some life stories, and we've come up with this webinar for tonight. The speakers, myself, Lou Vidotto, got over 40 years in resources and infrastructure projects worldwide. Most of my career has been in project controls. I was a site engineer when I first got out of uni, but wasn't very good at it. So I got into project controls and thought, hey, I'm good at this. So I tended to put my whole career into that. We have developed a project controls training program to share experiences, knowledge and basic skills to our profession. and certainly training is something that we're promoting as AACE and certification. Michael, maybe you can just pitch in and just give us some of your background.
Yep. Okay. Can you hear me okay?
Yes, we can.
Perfect.
Excellent. All right. Yeah, my name is Michael Wallace. My background is originally an engineer, then moved into project management. Predominantly, my life's been in oil and gas developments of of all streams. And I moved into an operations management role, and then moved away from oil and gas into, I guess, power generation and working with big superannuation companies with board advisory services. Since then, I've moved around a little bit, and focus is in primarily around risk, in which case I've been involved just recently with the Inland Rail project, which is a mega project at $13 billion, and the Melbourne Airport Rail Link. Currently, I'm working with Oricon with a few of their large projects as well, and I head up their risk management business for South Australia and Victoria. Thanks, Lou.
Okay, very good. So the agenda for tonight, we've got obviously a bit of an introduction. I'll run through the project process, talk about risk drivers and risk treatment, and then we've got a couple of case studies, certainly from Michael and one from myself. And then a few key lessons and takeaways, and certainly invite questions. We will probably stop for questions after risk treatment if anyone has any. Otherwise, certainly at the end, and we're open for a discussion. We'll go to open mic if people want to talk more about the presentation and other things that we've brought up in the webinar. So that's how I tend to propose to run it. So introduction. So Michael and I were talking about our common experiences on projects in our career, things that go wrong, things that you remember as major decisions that impacted the project. We had a bit of a laugh, but we landed on the Antonov effect. And that's certainly something in the case studies we'll talk a bit more. So tonight we want to share some of those experiences and takeaways. We'll talk obviously about the risk process a little bit, the project process, but we'll talk about the case studies and give some anecdotal musings on how it impacted us on those projects and what the outcome looked like. Introduction. One of the key things for me, us, is understanding what the project drivers are. And they're business drivers and project drivers. We tend to be on projects where we often get caught into the details and look at where we are. But as project controls professionals, project managers, I think the important thing is to understand what the project drivers are. And I'll talk a little bit more about on the next slide. But certainly, as we understand the project drivers, we come up with some critical risks for the project, and we need to put in place contingency plans to mitigate those risks. We're very mindful now of getting up risk registers and assign likelihood and consequence, who's assigned to manage that risk, and what the likelihood of what the impact is going to be. But it goes beyond that, and certainly in the case studies, we'll talk about things that really we didn't expect and how we handle them on those projects. Understanding the project drivers really drives your risk register as well. And also too, as project managers and project controls people, handling unforeseen critical impacts is very important to keep our head around that, because things do go wrong on projects. And what do we do to recover if we recover? And certainly keep our clients informed in our steering committees, etc. Again, a couple of case studies to highlight that. And then at the end, we'll sort of give some takeaways from this. The project process. This is a slide that I use when I do training, and it starts off really from the start of a concept phase right through pre-fees, fees, financial closure, if that's something that's part of that process for that project, project readiness, execution phase, and then operations. The reason we put this up is because at the start of an idea, the client or the developer will come up with what he wants to do to get a project off the ground and what he wants out of it. He'll develop maybe in unison with a project team, etc. But it's really about putting the ideas around what you want to get out of this project. And then in pre-feasibility study, you often have many options or capacities to achieve the business case. And out of the pre-feasibility study, you get one option which is the most suitable, which conforms or addresses the business case in the concept study. Feasibility studies, normally we study one option and then recommend. If at the end of a feasibility study, the feasibility study economics or NPV or the schedule or the cost don't meet what the owner originally wanted, we really should go around and do a pre-fees again. Maybe we didn't select the right options to study during pre-fees. And certainly the feasibility studies can be fine-tuned or upgraded or downgraded. And that really applies to any sort of project. My experience is certainly mining, but we look at different throughputs of plant, different outputs of product, different operating scenarios. So they'll all come into it. Again, the key thing is to be mindful of the journey that you started out on, which was what the owner wants to develop. Financial closure, often an owner has to go and raise funding to build that feasibility study. And we better be sure that we've addressed all the risks and the costs and the schedule and strategy so that the financiers are aware of that and we actually raise enough money to build the project. We do go through and do a risk ranging, etc., and say this is our most likely cost, but most often it's not the most likely cost. It's in that range of sort of P80 to P20. So it could land somewhere in between, somewhere in that range. Project readiness phase is really about implementing systems and processes, detailed planning, project preparation, addressing your risk register, and just looking at what your risks are that you want to you understand and how you're going to mitigate them. The risk also too, I should have said during the feasibility study, will be part of the contingent funding to mitigate those risks. Execution phase is really about building that option that was studied in the feasibility and approved and financed, and which you got ready, and then that leads to operations. So project a desire to get into execution phase as quickly as possible, and historically those projects are likely to go wrong somehow. But please, if you've got any questions, please message Cam and we'll address them as we go through.
You seem to be dropping out a little bit, Lou.
The present. Hello. that better? Hello?
Yep, can hear you now.
Okay, sorry about that. Yeah, the project process. So project controls planning, and that's where we tend to pick up the impact of risks in our schedule. It's really to build a project schedule in unison with the scope by WBS, the strategy and the estimate. We talk about the 4 pillars of the project, which are certainly the schedule, the scope, the strategy and the estimate. If you've got those all linked together with the common WBS thread, the project often stands a better chance of being successful. Planning. AACE are very prescriptive about planning, and I've put some of the relevant recommended practices on the screen. So RP 39R06 is project planning. It's applied in engineering and construction for capital projects. And certainly they're prescriptive about risk treatment. So RP 62R11 is risk assessment, identification and qualitative analysis. And then RP 63R11 is risk treatment, how you actually treat the risks that have been identified in the risk register. And I certainly urge everyone to read these RPs if you're talking about risks and planning, and certainly promote all of the RPs. They're invaluable tools. So risk drivers, risk management. It's really about identifying project and business risks via a risk register. We've had a situation lately where we've gone through some risk register development and getting the whole project team in to actually say identify what they think of the risks. And it was interesting because we had the planner identifying schedule risks. We had the Enviro guys identifying environmental impact risks and how they were going to tackle them and get approvals to operate the plant. We had the operating guys saying, well, if you build this here, it's going to impact the operations because it's going to restrict access to this part of the plant, and it could put health and safety issues up on the forefront. So I think that a risk management or risk identification process works pretty well, and certainly the risk register is something that we should all have on our table and be mindful of those risks, and we've got to mitigate them during the project process. The risk management, identify planned mitigation activities for high value risks, and build a risk management process into the project study process. It's not new, but I certainly want to reinforce that that's something that's extremely important in the way that we put projects together at the moment. So we're pretty good at identifying risks on a risk register and how we're going to deal with them. What about unanticipated risks that we haven't identified but could come and impact the project? For example, we'll see in the case studies things that weren't anticipated but are real risks to the project. And I won't steal Michael's or thunder on this one as yet. He can talk about that. But they certainly have an impact on cost and schedule. And what does that mean? The critical risk drivers really are, as I said, capital cost or schedule impacts, operating costs, weather impacts, external influences or other. And they're things that as project controls professionals and project managers, we need to be very aware of and drive the project so that we don't fall into those risks that we've identified. I certainly say that on a project, the critical risk is either capital cost or schedule. And I've had that discussion with a lot of people saying, no, we're going to build it on time and on budget. And that may well be true, but certain events happen that that impact what that how that impacts either the capital costs or the schedule. In our drive, for example, to reduce capital costs, we may increase operating costs. Is that something we want to do if we think that the budget's being overrun and we cut corners somewhere? If we impact the schedule, what does that mean on operating costs? I did a review of a project in Mongolia a few years ago, and they wanted us to assess how the project forecast was looking. And they'd awarded all their contracts, so it was really an assessment of all of the claims analysis and allowances for growth and changes, etc. They'd awarded all their contracts. And they said to me that the operations readiness budget was being underrun big time. But when I had a look at the schedule in as part of that review, they weren't underrunning the operations readiness costs. They were running late. And as it turned out, the operators were probably 4 months later ready to take over the plant, and the schedule was that the construction guys were ready to hand over the plant. And that had a significant capital impact, which has to be taken into account. And that's certainly something that I'm aware of when I'm doing project reviews. When are the operators ready to take the plant over? When are the construction guys ready to hand over? Weather events are significant. Do we have, if you look at the weather patterns in Australia now, for example, we're having non-standard weather events, and that can certainly impact Australia. It's certainly happening in Europe and probably in Asia too. Other external influences. I remember being on a project where the key driver was getting some alloys developed from the metal that was going to be produced. And they had plenty of time in the schedule. But the way the project was struck, what they said was that the cost was the key driver. And it wasn't, and that caused the financiers to walk away from the project. So you had the external influence of the financiers not continuing to fund the project. So it's really important that we all understand what the critical risk drivers and make sure we take those into account when we're developing the risk register and the schedule and our approach to the project. So risk treatment. I'll talk a bit about recommended practice 63 R11 risk treatment, and it requires skills and knowledge of decision and risk management professionals. It follows RP 62 R11 risk identification and qualitative analysis. So it's really RP 11 62 R11 talks about risk identification, and RP 63 talks about risk treatment. Once you've identified it, how you're going to treat those risks to make sure that they don't impact your project. In the risk treatment, I hope you guys, I'll go back. I hope you guys can read that pretty well. So the recommended practice is consistent with the TCM framework, section 7.6, risk management. So it says that the key actions to be performed during risk treatment are evaluating all response strategies, selecting an appropriate risk response strategy, strategy or combination of strategies, developing action items to support the selected response, validating proposed actions with assigned actions, including dates for implementation, ascertaining post-response targets and gains. What happens if it does, the risk does come true? What do you do after that? Ascertaining response plan resource requirements, updating the project schedule and or budget if the treatment results past decision making and change management criteria. So that's the impact of what happens if those risks happen. And identifying any secondary threats or opportunities that may arise from the response. So again, have a read of recommended practice. It's pretty good value. So what it says is really assign an action item, an action owner, devise and implement risk response plans for unacceptable risks. Obviously, no risks are acceptable, but some are probably very unacceptable. Assess controls and containment to mitigate the risk. Assess treatment or response options. Avoid, don't. So the treatments for risks are avoid, don't start the activity, reduce the impact, or transfer the risk to other parties. And obviously that's has a whole lot of other connotations, as an owner might want to transfer risk to contractors, etc. Or accept that it might happen and then monitor what does happen and how you recover from that. So what happens when risk mitigations fail and the critical path is jeopardized? Lots can happen. The key decisions are required which may impact the project viability. And we've got a couple of case studies, and Michael will talk about one, and then I'll follow through with one of my experiences from earlier in my career. But those key decisions need to be made in order to preserve the project key criteria. And certainly the options are stop the project, incur capital cost extra, or incur schedule extra, or change the scope. So every project is a little bit different, but certainly we've got a couple of slides to talk about our experiences. So what I'll do is I'll hand over to, I'll go to the next slide, and Michael will present case study 1. So if you're there, Michael, just give me a hoy if you want me to move the slide.
Okay, great. Thanks, Lou. All right. So, I just wanted to run through an experience which I had with the project a few years back. This is during my project management days. I was working for a pretty large organization and it just finished up a large project in Vietnam. And I was then asked to manage a project out of Russia. And I guess that I'll just go through these slides just one by one and just go through some of the experiences which I had in this very different environment to what I was used to working in. So it just says today that we're discussing the project where the critical path was threatened several times and would result in the project being mothballed. Now, the reason why I'm saying this is because there was a major shutdown. There was a 3-year shutdown at this facility, which was planned where they had to do vessel inspections. So this is a multi-billion-dollar complex, which if you did not get your project ready to be installed during that shut, then you were going to be that was going to be mothballed the project until another 3 years down the track. So it was a fair bit of pressure, but initially there was plenty afloat initially on the project, and I'll just go through these slides and you can see what actually did happen after that. So it just says there the response and mitigations may be of value in planning for circumstances that have been captured, and the lessons at the end of the presentation. So for privacy reasons, you can probably go on to the Google Maps and find where this place is, but it's for this purposes, it's Project X. So if this is, I'll just quickly show you, that's Sakhalin Island, which is in Russia. It's just to the south, you can see the very bottom left is Japan. So there's actually a line shown on Google Maps as well, where it is actually a division between the boundaries or the borders between both countries. And this island actually has is mainly a nature reserve, but it does have a lot of oil deposits and gas deposits. So if you can see there as well, if you can look very closely at that map in the top right, you can see where the oil platforms are for the island. You can go to the next slide, Lou. All right, so this is what it looks like in winter. It gets very, very cold in Russia, and especially in this place here, where you can see here, this is it's an oil platform which is about 5 kilometers offshore, and in winter you can actually walk from the shoreline through to the oil platform. So you need an icebreaker to actually get through to it. You can go to the next slide, Lou. All right, so just in terms of originally this facility was originally designed as being a gas plant, but when they finished drilling and they opened up the well, a lot of oil came through. So and that sort of changed the circumstances for the project as well, because of other things which will be shown in the next slide. But in terms of getting to this site, you can see on the right-hand side there the bogies which are set up for the module, and there was a port which was actually built specifically for the drop-off of the modules, and then there was about a 3-kilometre, 4-kilometre road which was built to take this heavy haulage for the modules to be placed into the location. So you can see also there's a red mark in the middle of that site map or the site photo, and that's where the new installation for the plant was, where I had to my team had to design and install the new bit of plant. So it was right smack bang in the middle of the operating plant. So down the bottom, I should say, yes, thanks for drawing my attention to it, Lou. There's a bit of a graphic there with the time bar, in which case we had to have everything on site 4 months before the shutdown. So if you did not hit that 4-month mark, it was mothballed the project. So we showed there that there was a little bit of float in there, but before getting to that cut-off point of 4 months. You can go to the next slide, Lou.
Yep.
Okay, so I just mentioned some of the pressures. At the time, I'll leave it a guess. I don't know whether I've put it on there, but I'll leave it a guess at what time we were doing this project. This is the value of a barrel of oil and over the period of time. And my project was somewhere between 2000 and 2015. So does anyone can guess when my project occurred? Anyone? Okay, it was 2007. You see the big spike at the very top? So that was when the oil price hit $140 a barrel, and that's when things went a little bit crazy in terms of the way in which operators were starting to operate their plants, because they can operate beyond 100% in terms of their performance. A lot of their machinery, like compressors, they can actually get special permissions from the OEMs to be able to wind them up and take them to almost 120% of their maximum operating range. So this just goes to show that in terms of the increased gas injection rate, so this is what actually occurred. There was an increase in the gas re-injection rate. So for gas re-injection, you re-inject gas to be able to draw out more oil out of the well, and that changed the operating conditions outside of the rely upon documentation. So we were at this stage we were doing a feed, and we were using data which we'd collected from the operators prior to this, prior to the project sort of kicking off. And what ended up happening was that we almost finished the feed and had the presentation to operations, and then we're told that no, that's not actually the operating conditions which we're operating the plant at. They've changed because now we've actually increased the re-injection. So at this time, they were re-injecting 1 billion scuffs a day, which is a lot of gas of re-injection to be able to get as much oil out of the facility as possible. So in terms of mitigation, we increase engineering resources and commence procurement process using preliminary data. And so what ended up happening, exchanges changed size, the whole thing got big. Of course, it didn't get bigger. The engineering didn't get bigger, like in terms of the equipment size. Sorry, it didn't get smaller, it all got bigger. So that created a lot of difficulties, especially at this time as well, because I was working within an organisation which had a matrix organisation, and I didn't have a ring fence team. So just in terms of here, you can see there was a delay, and that's just on that graphic down the bottom, showing that yes, we were hit by a delay, and we're starting to move along closer to the 4 months deadline before the plant, before the cutoff, before it was going to be mothballed, the project. So you can get to the next slide. Okay, so I was mentioning as well, places gets very, very cold. First time I turned up to the place, it was -26 when I got off the plane, and it was -35 on site. So it gets very, very cold. And you think that, okay, that's okay, but working in these sorts of environment, it requires a lot of, I think, a lot of experience. And what we notice here is that, and you can also see it actually gets quite warm in summer. So you've actually got permafrost in the ground in these sort of locations, which causes all sorts of troubles for civils. So here we can see here, so for the structural steel, it needed to be impacted as to -50. And in terms of steel, which comes to that, comes with that specification, it's only limited around the world. And this happened to be in the USA, where we had to get the steel. And if we didn't get the steel in time, it was going to delay structural fabrication and then just hit the project again. So in terms of the mitigation around that, we ended up batch testing a lot of the steel from over in the States, and we were flying, air freighting the steel across to Australia, where we're doing the fabrication. I'll also point out this is an international project. There was the equipment was being manufactured all over the world. There was pipe spool fabrication being done out of Scotland. There was engineering being done out of Russia, being done out of Australia. It was truly an international project. So in terms of that mitigation with that batch testing, it was a partial success. There was a call which had to be made in terms of, Michael, we do not have the test results yet through for this for 40 tons worth of steel. You got to make the call whether or not you put it on a plane or not. So the call was yes, put it on a plane, and then after the plane had taken off, I got the news that it had failed the test. so that was a bit annoying, but yeah. So again, another bit of slippage. You can go on to the next slide, Lou. Okay, so good here. So earthquakes and heavy heat exchangers. So with this, it was a case of everything over, like in this part of Russia, the earthquake loads are very high. I said before that because of the information which is provided to us during the feed, it actually changed because of the price of oil and the way in which the plant was operating. So what we end up having to do is it has a significant impact in terms of the size of the steel, and we're talking about we had 200 tons worth of exchanges, and unfortunately in these conditions you can't actually use concrete too well. You can't pour the concrete in this cold, so a lot of it was steel driven piles with a diesel hammer and with a Motor crane, which is shown up there. That's actually the crane which we used on site. So I guess that with this, it was a case of, with knowing this, we performed engineering assessment for bolted connections, for the possibility of changing from a modular to stick for quicker beamline production times. But we found that the problem with that is that we were getting failures with regards to the design, simply because the bolted connections weren't able to take the stresses which we need for the sections and for the structures to hold onto the equipment. So again, that led to more delays within the project because of the time for manufacturing in a project workshop as opposed to a beamline. So if anyone's got the opportunity to be able to use a beamline where it's guaranteed a certain tonnage per day, and if you can have bolted connections, even if it's for modular purposes, it's definitely the way to go rather than being in a project workshop. Okay, you can go to the next one, Lou. Okay, so because it was we were working to Russian standards, the Russian standards referenced AWS, which is the American Welding Society. The manufacturer or the fabricators which were used in Australia, they weren't used to using those procedures or electrodes, so it was new to them, but they thought it was not going to be any different to what they're used to. So new welding consumables, the fumes were a lot heavier, and it led to sickness of a lot of the welders in the fabrication shops. So I only found out about this after it had been going on for about a week, when I finally got a call from the fabricator's manager and being told that it's a third person had to get sent home sick. So that was an instant stoppage because my client is a zero tolerance around safety breaches. So that was an instant stoppage to the project until an investigation was done. So I guess that this was really a response. This was not an identified risk at the time, and I'll go into that a little bit later. But yeah, it was a stop work, perform safety audit, and introduce new ventilation and hygiene measures, approve overtime to recover lost time. It was partially effective, a limitation of qualified welding resources, constrained working hours. So it was just and that actually led to some fatigue in some instances. So that was another discussion with the fab shop with regards to, we cannot work the fabricators out like to a point where it ends up becoming unhealthy. So the next slide. Okay, so this is a pretty busy slide. Requirements mapping. This is what we didn't really. This is back in the time when there wasn't too much requirements mapping. Now there's actually, there's systems, requirements mapping systems, which are out there now, which are fantastic. But at that time, we weren't actually using them. And I guess that this is if I go through the flow going from number 1. It says that there's a tender offer for fabrication missed the pile caps as an exclusion. So after the RFTs, the request for tenders were let out, and when we received them in, one of the engineers who was reviewing the bids forgot to see that there was actually an exclusion in there for pile caps. Now you'd think normally, pile caps, that's not a problem, is it? But I think if you remember back to one of my previous slides, it had to be to -50. So you can't just go and get it. You can't get it in Australia. You have to try and locate it somewhere in the world. So we were down pile caps, and it came at a really bad time when the client was saying, Mike, we need those pile caps. We need at least the certificates for the pile caps so that we can start developing our welding procedures. And they did not like it when I said, we don't have the material. So that didn't go too well. So, and that was going to be a problem. In terms of, there's another example here with regards to the pile coating non-compliant due to poor specification clarity. Piles already delivered, and cold weather prevents field coating. So this was a client spec which had gone through to Korea, and the Koreans read the spec one way, and it confused me as well when I read the spec in terms of coating DFTs. Now this is for coating, so it's a coal tar epoxy which is on these piles, and the way it was actually written was a little bit ambiguous. Not according to the client. The client was clear that it makes plenty of sense, but it was quite ambiguous, and unfortunately that meant that I was going to have a problem. So response and mitigation, the first one there with regards to the pile caps, air freight, special steel and divide scope between two workshops, air freight to site. These weren't just like plates, they were actually fabricated pile caps. There's a lot of welding involved with the pile caps, which was quite demanding, and perform engineering assessment for cathodic protection of the piles. So in terms of, we couldn't actually recoat the piles. The company or the client ended up having the constructor turn away us trying to get in there and do the coating, and they said, no, you got to come up with another way, and that was cathodic protection. So that was thought to be okay. The only concern around that also was a risk that it was going to interfere with a lot of the other cathodic protection which was on the plant, which could have been problematic. In terms of success, pile caps were received in time. We were actually able to get them air freighted in. And just noting that the cathodic protection could be retrofitted after the plant shut down. So even if the installation could occur, once the shutdown occurred, then after that we could actually retrofit the cathodic protection, and that was okay. So next slide. Okay, this is the Antonov. So as Lou was saying before, we both had the Antonov stories, and this was really a delays in structural fabrication, difficulty securing ship consignments, with delays to open deck cargo. So large open deck cargo they're not available all the time, and especially given that there was no way of really knowing confidently that we're going to be able to get a ship for that cargo in the right amount of time when we were going to be finishing the fabrication. So in terms of mitigation, Panalpina was the logistics consultant and globally for the customer or the client. And because we couldn't get hold of a ship, they went to put the Antonov on standby for the project to be able, and we did an assessment of the airfields to be able to get it from Australia across into Russia. So there was another one as well with just being able to identify ships that can be redeployed at a premium cost. So we were looking at bringing ships in to be able to give them additional money to be able to make a special trip to pick up our gear. That was a success. We did manage to get a ship from PNG who was, for a nice cost, was able to make a pass through Melbourne to be able to pick up all the fabricated items, because these are big fabricated pre-assembled units. So with that, so just a bit of trivia is the biggest user of the Antonovs worldwide is actually the American military. So they have the biggest contracts with and the most use of those Antonov fleet. So trying to compete with them to be able to even get an Antonov is difficult, but it just happens that Panalpina do have quite frequent dealings with the American military as well as Antonov. The next slide, please, Lou. Okay, so key lessons. There's so many lessons which you'll learn out of this, which is great. I didn't get the sack, which is good. We managed to be able to get we managed to get everything installed in time, or to site on time. It did cost a lot of extra money, so that we were nowhere near. We're way over budget for logistics. I guess risks should be considered when engaging a new contractor that's unfamiliar with nuances of the site, customer, logistics, specifications, subcontractor capabilities, etc. So, as I said, it was an international project. I've come across from Vietnam, a large project, into an unknown environment. And I think that, and also with the team which I had, none of my team had experience with delivering projects in such conditions. There were going to be a lot of surprises. So in terms of the definition of project, with all the learnings which come through a project, there were plenty to be had on this. And if I can go to the second one there, the contractor has limited Asia Pacific supplier relationships that would have greater capability. So in terms of it's the contractor supplier relationship. So yeah, so in terms of even with our suppliers, because we were, if we had relationships and we'd already had used a lot of the I guess the paint yards, the pile suppliers out of Korea, had we been familiar with the suppliers and known how to work with them, and then being familiar with the client's requirements, then that would have been it would have avoided a lot of the difficulties that we had on the project. And just another one there, change management is not performed effectively when external environmental factors such as crude oil prices trigger a quick operational response. So yeah, something which you don't know. I mean, you saw how quickly that spike went up to $140 a barrel. We hadn't factored that in when we were looking at the project. And I think that was the last one, wasn't it, Lou?
Yep. Thank you.
Right. Thank you.
That became a critical project driver, get that project built as quickly as possible, didn't it?
Yeah. No, absolutely.
Yeah. Yeah. So case study 2. I worked on a project when I was not far out of uni called Octetti in the mid-1980s. So the map says that we actually transshipped from Moresby and brought barges up to up the river as far as from Kiunga and up to a place called Tabooble, which is about 300 kilometres. And then we transship onto truck and take it the rest of the way up to the site. So the project was reliant on barging to Kiunga, and that's where we did our construction staging. And even now, Kiunga is a fairly big river port. The monthly rainfall in that part of Octetti is about 330 mil up to half a metre per month, and it rains 16 to 22 days per year, so a lot of rain, and it comes down heavy and often. So what happened was that there was an unplanned risk in that the drought occurred for about a month on the Fly, and the Fly River dropped by about 16 metres. So consequently, barges that were coming up to Kiunga were stranded on sandbars, and they were stuck. They could not move forward or back. So that put a chokehold on the project logistics. There were over 2,000 men at site, and there were ongoing earthworks and construction activities. And at that time, there was only limited aircraft interfacing. So the consequence was that the critical activity meant the project was in a dire predicament. There was food shortage, diesel shortage, including spares for construction equipment, and also for the power station. The power was driven by some a fairly hefty diesel power station, and obviously water. So what did the project do? And it comes back to full circle. We got some Antonovs in. So the project engaged Antonov aircraft to airlift food, water, beer was a big thing. Not a giant thing, but certainly something that got on the planes, and diesel. So it was a huge cost to the project. The schedule was impacted, but certainly it was not. Didn't kill the project, but certainly the cost to the project were enormous, and it did minimise the schedule loss. It took some months before the full barge capacity was back on the river. So the aircraft actually formed a bit of a lifeline to the project for a while. So that's very, very briefly. It was in my younger days, so I'm going a little bit on memory, but I certainly remember. And when Michael and I talked about the Antonovs, I remembered this project in particular. Next slide is really about unplanned risks. Some takeaways are reality in projects. So the key drivers for decision making are really, is it the capital cost? Is it the schedule? Is it the operating cost? Is it the return on investments? And those key drivers are really to be used for decision making. As Michael said, the schedule was key for a key driver for them. They had to get the job built. And I don't know what the impact on capital cost was, but I guess it was significant. And same in the Octetti project, the schedule was preserved, and certainly the capital cost took a hit. Operating costs, if there are changes to the scope and changes to whatever, and the impact on operating costs are impacted, that could be key to the project viability. And therefore, do the owners want to continue on the road when they think that their return on investment might not be as good as they thought it was when they started the concept phase? So certainly that takeaway is about understand those and be conscious of them, because those decisions that will need to be made probably on most projects in one form or another. So that's the end of our presentation. I certainly think that we're open to questions and discussion. Certainly happy to hear about other people's experiences on projects. So thank you for listening to us.